This is the 3.5 day 2 video for your notes. We've already spent 2 days kind of laying the foundation for slope-intercept form, and we've talked about it some previously when we were talking about standard form. So the last 2 days, all we did was concentrate on slope. And remember, slope is the same thing as rate of change. Okay, so now we're looking at another form of a linear equation, and that form is y equals mx plus b. And I played you guys a couple of songs today to help you remember, but what you need to know is that y represents your dependent variable. M, that's going to be our slope. Remember, slope is the same thing as rate of change. X is your independent variable, and b is your y-intercept. So remember, we talked about y-intercept when we talked about standard form also. So if you look up here in our core concept, B, that's that point where the line is actually crossing the y-axis, and that's why we call it the y-intercept. Okay? We've been talking a lot about slope for the last 2 days, so hopefully you remember that you can calculate slope on a graph by counting the rise over run ratio, or we could calculate it using ordered pairs, using that formula, the y2 minus y1 over x2 minus x1. Well, now, if you have an equation, we can actually look at the slope because it's going to be the coefficient of x if it's written in slope-intercept form. Okay? So let's work a little bit with this. So in our notes, the first thing that we did was we looked at some equations and we just tried to identify the slope and the y-intercept just by looking at the actual equation itself. So notice on the first equation, on equation A, this one's already nice and written in slope-intercept form for us. So we know that in A, our slope is equal to 3 because it's already written in the form of y equals mx plus b. And I know my slope is the number in front of x. I can also identify b, which remember b is my y-intercept because that's the number that's being added or subtracted. So in this case, my y-intercept would be -4. Okay? So that's when it's already written in slope-intercept form. Now notice on the second example on b, we just have y equals 6.5. So we've been talking about vertical and horizontal lines for almost 3 weeks now, and I've given you several ways to remember. So when you have y equals a number, hopefully your first inclination is, oh, that's that acronym HOI. Remember, HOI stands for horizontal lines, have 0 slope, and they are y equals a number. So notice here, I don't see the variable x. That's how I knew it was HOI. Okay, so if this is a horizontal line, I know that all the y values are 6.5, and that tells me that my slope would have to be 0. Okay, so that's my m, or my slope. I also see that y is equal to 6.5. That means that the y-intercept must be 6.5. Okay? So it looks a little bit different, but if you know your acronym and you know that y equals a number is a horizontal line, then you can still calculate your slope because you know horizontal lines have a slope of 0, and you can also calculate your y-intercept because you know that all the y values in a horizontal line are going to equal, in this case, 6.5. Okay, so we've looked at 2 types. Now we have a third one. Now notice that this equation is not written in slope-intercept form, it's written in standard form. So the first thing I have to do is solve for y. So in order to do that, I am going to add 5x to both sides. When I do that, these are going to cancel, and I'm left with negative y equals 5x minus 2. Then, since y is negative, I'm going to divide everything by a -1. So I wind up with y equals negative 5x plus 2. Dividing by a -1 changes the signs of everything, okay? And now I can identify my slope and y-intercept. My slope is the number in front of x, which in this case is -5, And my y-intercept, remember that's b, in this case is 2. Okay? All right. Now here are 3 examples for you guys to do that are similar to the last 3 that we did. So I'd like you to do these. Go ahead and pause the video and then you can check your work with mine. Okay, so just like on the last 3 problems, these were 3 different styles of equations. So number 6 was already written in slope-intercept form for you, so it made it a little bit easier. You knew that -6 was your slope because that's the number in front of x. You knew that +1 was your y-intercept because it's the number that is being added or subtracted, and that represents your y-intercept. That's your constant. For number 7, when you had y equals 8, as soon as you saw only y equals a number, you should have thought of your acronym, HOI. That's a horizontal line, which means it has 0 slope, and that would be y equals 8. So 8 also represents your y-intercept. For number 8, this equation was written in standard form because x and y are on the same side, so I had to solve for y because I wanted to put it into that slope-intercept form. So first I subtracted x from both sides, and then I divided everything by 4. Now the part that might have thrown you off a little bit is this first part right here. When I do negative x over 4, remember that's negative 1x, so that's where this negative 1/4 came from, okay? And then I kept my y-intercept as an improper fraction, so it was negative 10/4. So my slope is negative 1/4, my y-intercept is negative 10/4, okay? Now if you were to divide out negative 10 divided by 4, you would have gotten negative 2.5, which is also correct, okay? So the next part of our notes, we did a little review. We talked about slope-intercept form and standard form, and we've used these for different things. So we have graphed using both of these. So let's review slope-intercept form first. So for number 9, they asked you to graph. So I'm going to sketch a graph over here. And because this was already written in slope-intercept form, it made my life a little bit easier. The first thing I'm going to do is plot my y-intercept, which in this case is at negative 4. So I know that b is negative 4. So I'm going to go ahead and put that on my graph. So 1, 2, 3, 4. So I put a point on negative 4. Now my slope here is equal to 4, but because it's a whole number, I'm going to write it as 4 over 1. Remember, we want that slope to be that ratio of rise over run, because that will help me to graph. So in order to graph, I'm going to start on my y-intercept, and I'm going to count my rise. This rise was 4, because that's my numerator. So I'm going to go up 4. So 1, 2, 3, 4. And then I'm going to run 1 to the right, because that's my denominator. Okay, so when I run 1 to the right, that's going to give me a point right there on the x-axis. Then I'm going to take a straight edge or something straight, and I'm going to draw a line through those points. Now notice it asks me to identify the x-intercept. I can clearly see that if I rise 4 and run 1, that my x-intercept is going to occur at 1, 0. Okay? All right. Let's go ahead and look at number 10. Now number 10 is written in standard form. And remember, we use intercepts to graph when it's written in standard form. So that's where you plug in a 0 for y and calculate your x-intercept. So to find my x-intercept here, all I'm going to do is put a 0 in right here for y. That would make y 0. So it would go away and I would be left with 3x equals negative 3. To solve for x, I would divide both sides by 3, and that would tell me that my x-intercept would be equal to negative 1. Okay, so my x-intercept here would be negative 1, 0. Then, if I wanted to find my y-intercept, I would plug in a 0 for x. Well, if I plug in a 0 right there, look at what I'm left with. I'm left with y equals negative 3. So when I graph again, so I'm going to draw my coordinate plane, I only need 2 points to graph. I need at least 2 points. So here, I knew that my y-intercept, remember I plug in 0 right there for x, and I see y is -3. So 1, 2, 3, that gives me my y-intercept. And I already calculated my x-intercept at -1. So that gives me my points. I can draw my line through those points. And then I already found my x-intercept. It was 0, -1. Right there. I calculated that first. Okay? So there's 2 different ways that we did this. The first way, I actually used slope-intercept form. So I plotted my y-intercept at -4, and then I used my slope. I rose 4, ran 1, and that gave me my x-intercept because the graph was touching the x-axis at 1, 0. On the second example, since it was written in standard form, I calculated my x-intercept, meaning I put a 0 in for y and I solved for x. That's where I got -1 from. So I plotted my x-intercept at -1, and then to find my y-intercept, I plugged in a 0 for x right there, and I saw that y equaled -3. So I put a point on -3, and I drew my line through it. Okay? Notice this line has a positive slope because it slopes up, and this line has a negative slope because it slopes down. Notice number 11 is written in standard form, so why don't you go ahead and pause and see if you can do that one on your own. So on this one, the first thing I did was calculate my x-intercept. So I put in a 0 for y, and I noticed, hey, x just equals 6. So my x-intercept occurred at 6, 0. So I put a point on 6 on the x-axis. Then to find my y-intercept, I put in a 0 for x, which left me with 2y equals 6. So to solve for y, I would divide by 2, and that told me my y-intercept occurred at 3. Then I drew a line through those points. Notice this line also has a negative slope because it's sloping down from left to right. So this last problem is combining what you're supposed to know about function notation and independent and dependent variables, and then all the different parts of a graph or an equation. Okay? So it tells me a linear function g. So they're calling this function g of x, basically. But remember, g of x is the same thing as y equals. Okay? So we have a function g where the dependent variable increases 3 units. For every 1 unit, the independent variable increases. Okay? So let's think about what that looks like. So if they are telling you that the dependent variable increases by 3 units, that means that your change in y had to be equal to 3. And then it says for every 1 unit, the independent variable increases. So that means my change in x had to be 1. If they are giving you the ratio of change in y over change in x, remember what they're giving you is your slope. Okay? So we've just identified our slope. Now, the next part is this information that they gave me at the top right here where it says graph g when g of 0 equals 3. Okay, so let's think about what that means. Remember, in function notation, g of x, so they've replaced the x with a 0. So the ordered pair that they're giving me right here is that x is 0 and my output, or y, would be 3. So 0, 3 has to be my y-intercept, okay? So that's the first thing I'm going to graph is my y-intercept. So I'm going to go to 3 on the y-axis, and I'm going to put a point. Then I'm going to use that slope ratio, that rise over run, that 3 over 1, to graph another point, okay? So remember, I can go up 3 over 1, but since this is going to run off my graph, what would happen if I reversed that and went down 3 over 1? Then I would be on my graph right here, which actually is my x-intercept. So my x-intercept on this graph would be -1, 0. I can see that by using my slope. If you want to check if I rise 3, 1, run 1 to the right, I'm back on that second point that I had. Okay, so that'll give me my line. Sorry, these aren't the straightest lines, but if you were doing this on paper, you would be using a straight edge, hopefully. Okay? All right, so I'm just going to review how I went through that. So the first thing I did is I read the verbal model, and I noticed that they were giving me a ratio. They told me the dependent variable, that's my change in y, increased by 3 for every 1 unit of the independent, that's my change in x. So I wrote that as a ratio of 3/1. That was my slope. Then I went up here and I noticed that they wanted me to graph g when g of 0 equals 3. So I knew that the x-coordinate was 0 and my y-coordinate was 3. When I graphed that, I noticed that that had to be my y-intercept. Then I used my slope in order to find the x-intercept. I went down 3, left 1. And think about what that means, guys. If I do -3 over -1, that reduces to +3/1. So those are equal. Okay, that's how I went in the backwards order on my slope. I just went to the down and left. Okay, my line slopes up, so I know that my 3/1 ratio is right. It's positive. Okay? All right. If you are struggling with any of this, we will be having an activity day tomorrow in class to practice some more, but make sure you come in for tutoring if you need extra support. Y'all have a great day.